Hello, welcome back. Last time we talked about 7.3, and in this chapter I will I will focus on 7.5 because for 7.4 it is about proofs related to parallelograms, which means you have to use all the concepts you learned in chapter 7.1 to chapter 7.3, or even also about congruent triangles, similar triangles, so on and so forth, to finish more exercise, which are mainly about proofs. So you may read the examples yourself and finish the corresponding exercise in your self-assessment booklets. Okay, so this time we focus on 7.5. In this section, we will introduce two theorems. One is called midpoint theorem, and the other is called intercept theorem. Okay, and this is the last section of this chapter. Okay, so start from midpoint theorem. Midpoint theorem means when we have triangle, for example, triangle ABC, the line joining two midpoint, this to a midpoint, the line joining two midpoint, we have two results. The first one, this will parallel to the baseline, the last side of the triangle. Second, the length of it will be half of the base of the triangle. Okay, so two results. If we have one triangle, we have two midpoints on two sides, then the line joining these two midpoints will be parallel to the last side, and also the length is half of the last side. And this is so-called midpoint theorem. You may use this abbreviation as reason. Okay, see some exercise. This one easy, just simply apply it. So this time we have triangles and we can see that, okay, MN are midpoint. So in your mind, please recall midpoint theorem because we have triangle and we have midpoints. So now we have to find X and the length of MN. X first, because we have two midpoints, when you write down your presentation, please state that, okay, something equals to something and something equals to something means that M is midpoint, this one, M is midpoint and N is midpoint. Therefore, we have the first result from midpoint theorem, MN parallel to EF, and give me the corresponding reason. Okay, MN parallel to EF. That's why X equals to angle DEF. The reason is corresponding angle. So X is 45 degrees. Finish the first part. And the second part, the length of MN. This comes from the second result of the midpoint theorem. Because similarly, M and N are midpoints, so the line joining them, this one, should be half of the base. So MN is half of EF because we state the fact that M and N are midpoint here. So you may use therefore to indicate that this is the first result, and also add a therefore here to indicate that this is another result from the same reason. So midpoint theorem again, and the answer for CM. That's it, easy, right? And this example, we have more than one triangle, so a bit complicated. This time we have some midpoints. D and E are midpoints. Actually, D and C are also midpoints. We have two triangles here, and we have to find the length of CB here. So the length of CB, you can see that it is included in the triangle ABC. So focus on triangle ABC. In triangle ABC, D and E are midpoints. So we may apply midpoint theorem again. So we have to find the length of BC. So let's use the second result of midpoint theorem. DE should be half of the base BC. So by midpoint theorem. And once again, you have to tell me the result. So I strongly suggest you to write it down. Tell me that, okay, since something equals to something means since D is midpoint and E is midpoint. Therefore, by midpoint theorem, we know that D is half of BC. So calculate BC is 4 cm. So this is part A and this is part B. Part B, find angle ADE. Where is it? ADE here. Last time we used the triangle on the right hand side, the yellow one here, to find out something. So this time we have to use another one. Let me use green. This time you may focus on this triangle. Okay. In this triangle, you can see that D and C are also midpoint. D and C are also midpoint. And also, let me write down the result from part A. This is 4 cm. Okay, this is proved in part A. Okay, focus on the triangle in green. D and C are midpoints because D is directly told the question tell you that this is midpoint directly, and for C you can see that okay, this is 4 cm, this is 4 cm, so obviously C is the midpoint. So you can see that in the solution, I think I can amend the solution. Use red. I would say that since GC equals to 4 cm equals to CB, for me I write it this way. Therefore, C is the midpoint. And add one more. And also FD equals to DB. So here, this one we tell us that C is the midpoint, and this one we tell us that D is the midpoint. So you can apply midpoint theorem. Therefore, DC parallel to FG. This is the recent midpoint theorem. For me, I'll write the theorem in THM. As a result, angle DCB equals to angle FGC, corresponding angles again. DC parallel FG equals to 65 degrees. And therefore, angle ADE, the required angle equals to angle DCB equals to 65 degrees. The reason is corresponding angle again, because in A we proved that DE parallel to, oh, did we prove it? No. We haven't said it. CB. So let me, can I move this part downward? Yeah. So leave some space here. Okay, we have to explain the result DE parallel to CB. Okay, becomes blue, never mind. Make use of midpoint theorem again. So because AD equals to DC, or actually you may write some words if you want. In another way, you can say that okay, because D and E are midpoints of AC and AB respectively, because you say two things in the same sentence. So by midpoint theorem, you know that DE parallel to BC. This comes from midpoint theorem. Okay, and then follow the results here. So for me, I'll write the solution for part B in this way instead of that one. But actually, the idea is similar. The idea is similar, but just different from presentation. Okay, last example 21. This time we have any quadrilaterals here, ABCD, and we find 4 midpoints EFGH on each side, and we join all midpoints, and we have another new quadrilateral EFGH. And the question tells you that EFGH is always a parallelogram and asks you to prove it. Okay, ask you to prove it. So here we have the solution. The first part just focus on triangle ABC. This one. EFGH are midpoint. Okay. Maybe let me. We can write this way. Midpoint. So the two lines near it should be the same. Okay, midpoints. Focus on triangle ABC. So in triangle ABC, E and F are midpoint mentioned here. Therefore, by midpoint theorem, you have two results. They are parallel and the length relation. And then the second part, you can focus, this is the yellow part. And then the second part, you may focus on the green one, this triangle. Okay, in this triangle, H and G are also midpoint mentioned here. And then by midpoint theorem, you have two results parallel and also the length. So now, try to combine the result. If you combine these two results, you can see that EF parallel to AC and AC parallel to HG. So you get this one. EF parallel to HG directly. These two are parallel. And also, if you combine these two results, EF is half of AC, and actually GH is also half of AC, so EF actually equals to HG. So these two are equal. So you can see that in quadrilateral EFGH, we have a pair of opposite sides parallel to each other and have the same length. So this must be a parallelogram. The reason is two sides equal and parallel. You learned it in 7.2, should be 7.2. Okay, so this is the solution of this example. So you can see that actually midpoint theorem is not very difficult. When you see the question gives you a triangle and tells you that, okay, we have two midpoints on the triangle, then you may recall in your mind that, okay, maybe we have to apply midpoint theorem to this question. Okay, so this is the end of midpoint theorem. And then goes to another one. We call it intercept theorem. Just remind you some vocabularies. If we have some parallel lines or some horizontal lines here, and we have one line just directly passing through all of them, we can call it transversal. Okay, we can call it transversal. And you can see the transversal is cut by the horizontal line into two parts. We have three horizontal lines, so the transversal is cut into two parts in the middle. We can call these two parts intercept, but never mind, just a name. So this is the intercept theorem state in your book. But for me, I would like to give you a general version. A more generalized one means a stronger version. You may directly use it for me. You may directly use it. So I stated here a stronger version. Also, actually, it's intercept theorem. It's just a stronger version. I suggest you to memorize the stronger version and use the stronger version instead. Okay, when we have some parallel lines, okay, poor drawing. When we have some parallel lines, never mind, actually, three or four or many, never mind, at least three first. And we can draw two transversal on it, 1 and 2. Okay, for the first transversal, if it is cut in the ratio of A to B, then for the second transversal, it is also cut in the ratio of A to B. Okay, so let me give it some name. If we have A, B, C, D, E, F, okay? In the figure, if AB parallel to CD, parallel to EF, if we have some parallel lines here, and for the first transversal, we know that, never mind, not N, just use N. Okay, if we have some parallel lines, then the ratio of the transversal, the first transversal, the blue one, is cut into two parts, AC and CE. The ratio between AC to CE equals to the ratio in the second transversal cut by the parallel lines, equals to BD to DF, actually. Okay, the ratio between them should be the same. So if this one is A to B, then this one is A to B. Like this, a stronger version. So go back to the weaker version in your book. Actually, your book specializes the ratio to 1 to 1 only. So you can see that this time we have some parallel lines here, and now we have two transversal. If we know that for the first transversal, this one to this one, the ratio is 1 to 1, means they are equal length, then the ratio between in another transversal should be also 1 to 1, means this one equals to this one also. Okay, should be one line. So in your book, the intercept theorem mentioned is a weaker version. For me, I suggest you can directly use the stronger version in ratio, but not only equal length. Okay, equal length means in the ratio 1 to 1. So I'll try to apply the stronger version in the following exercise. Okay, this is the solution from your book, read it yourself. If I use a stronger version to finish this question, you can finish in this way. Okay, since we have AB parallel to CD, parallel to EF, parallel to GH, this time we have 4 parallel lines. So the transversal are cut into 3 parts. Okay, 4 lines cut into 3 parts. So therefore, we should have AC to CE to EG, this ratio equals to the ratio in another transversal BD to DF to FH. This result comes from Intercept theorem. So you have to spell the name Intercept. And now AC to CE to EG actually means 4 to X to Y. So BDDFH is 3 to 3 to 6. Okay, so by comparing this ratio, by comparing this to three-termed ratio, you can see that, okay, means 4 to X equals to 3 over 3, the first two terms, so X equals to 4. And also when you compare the last two terms, or the first term and the third term, easier. The first term and the third term, you can see that 4 to Y equals to 3 to 6 means 1 to 2. So Y equals to 8. And no units for X and Y. So for me, I will finish in this way. Okay. So it goes to the next one. Okay, we have another, called Intercept theorem again. Why? Because actually, other than applying Intercept theorem to the case with parallel lines, we can also apply Intercept theorem to triangles. Okay, to triangles. Just imagine that we have another line passing through A, which is parallel to this 2. So actually it seems that we have 3 parallel lines and we have 2 transversal passing through them. But in particular, the 2 transversal and also one of the parallel line meets at A. Okay, meets at A. So they just form a triangle. So similarly, other than the theorem from the book, we can have a stronger version also. Also Intercept theorem. Okay, if we have a triangle, when we draw some more lines parallel to the base, okay, the triangle I call it ABC, and the lines here we can call it MN. Okay, if we know that MN parallel to BC, then the ratio of the 2 sides of the triangle cut by the MN means AM to MB should equals to the ratio AN to NC. Okay, this one is also called Intercept theorem. Just in particular, apply it to triangle. So this is a stronger version. Use ratio instead of just equal. Equal means 1 to 1 only. So try to apply the stronger version in the following examples. Okay, this one. Part A first. Ask you to prove that BT equals to TD. Okay, this is the solution. Seems easy. If I use the stronger version to rewrite the solution, it becomes something like this. Okay, focus on the triangle here because BT is here. Okay, focus on this triangle. We know that this one is parallel to this one. We have a pair of parallel lines in the triangle. So you may apply Intercept theorem to it. So since AB parallel to EF or ET, never mind, we have the ratio BT to TD. Okay, the ratio cut by the horizontal line equals to the ratio in another transversal AE to ED. And you can see that AE equals to ED, which means this is 1 to 1. Oh, where's the reason? Intercept theorem. Okay, 1 to 1. So you can see that now BT to TD means 1 to 1. As a result, BT should equals to TD. So it is proved. Similar, very easy, but we write in the stronger version of Intercept theorem. Okay, part B. Is T the midpoint of EF? Is it the midpoint of EF? Means is ET equals to TF? Equivalent question. Is ET equal to TF? You have to answer in this way. Okay, 26 here and 34 here. 34. Not good. This one. 34 cm. Okay, so you have to calculate the length of ET and also the length of TF. This time, in part A, you prove that DT equals to TB. So T is the midpoint of DB. Okay, so now in the triangle on the left, this one, I can see that E is the midpoint and T is the midpoint. So in a triangle, we have two midpoints. Please we call it midpoint theorem. So we can try to make use of midpoint theorem. Okay, since E and T, or if you don't like to write words, you can write this way. AE equals to ED and DT equals to TB. Okay, E and T are midpoints. Then by midpoint theorem, you know that, okay, ET should have the length half of the base AB. This is midpoint theorem. So it means this is half of 26, so 13 cm. Okay, 13 cm. And we know that EF equals to 44, so taking the difference, we know that the length of TF equals to 34 minus 14, which is 21 cm. So you can see that since ET does not equal to TF, therefore T is not the midpoint. Not very difficult, quite straightforward, but apply some new theorem you just learned. Okay, any problem? Okay, a kind reminder from your book. In the past experience means some senior form students or some students just learn these two theorems. They will mix up these two theorems because these two theorems they were about some midpoints or about some parallel lines. But actually, I don't think you will mix them up. For midpoint theorem, we should start from two midpoints. If you have triangles with two midpoints, then you may apply midpoint theorem. And the result is we have parallel and also something about the length. And then for intercept theorem, if we consider the stronger version, not this, if we consider the stronger version, means we have to start from a triangle also. But this time not start from two midpoints. Instead, we have to start from a pair, at least two parallel lines. Okay, at least two parallel lines. And then the result should be some equal ratio. The result should be some equal ratio. AM to MB equals to AN to NC. Okay, the result should be some equal ratio instead. So I don't think you have a high chance to mix them up. Okay, so is it the last example? Yes, this is the last example. Try to use both theorems in the same question and try to distinguish between them. Okay, so we have a figure like this and we have so many equal signs. Okay, the first part you have to prove that AG equals to GF. AG equals to GF. You have to prove that this one equals to this one. Can you see the color? Okay, these two parts should be the same. So how can you prove it? You have to do in this way. As I usually use the stronger version, so maybe I can rewrite the solution. Okay, the first part, we can focus on this triangle. The first part, you may focus on this triangle. In this triangle, E and F are midpoint, so maybe we can use midpoint theorem. Since DE equals to EB and BF equals to FC, okay, don't be lazy, write down all reasons. Therefore, we have EF parallel to DC. Okay, this is midpoint theorem. This is the yellow part. This is the yellow part. Okay, after that, you get a result. These two are parallel. Okay, these two are parallel. Then you can focus in the next triangle, this one. Actually, the most difficult thing for this question is in the figure you can find so many triangles. So you have to take the correct one and try to apply the theorem to it. Okay, the second part here should be, now you know that DG is parallel to EF. In a triangle, we have a pair of parallel lines. So you may apply intercept theorem now. Therefore, the ratio between AG to GF should equals to the ratio on another side, AD equals to DE. This is intercept theorem. Okay, AD, let me rewrite it, colon, should be 2 dots instead of 2 short line. Okay, so this one, AD equals to DE means they are 1 to 1. Okay, so now you know that AG to GF is 1 to 1 as a result. This means AG equals to GF. So the result is proved. Okay, so part A is finished. This is part A. So any problem? No, move on to part B. Part B, this time you have to find out DG, the ratio between DG and GC. Okay, in part A, we proved that these two are the same, so draw on it. And then this time we have to find out the ratio between DG and EF. Oh, what is the ratio between not EF, DG to DC? What is the ratio? Okay, continue the first part. Continue from part A. Focus on this triangle again. Okay, in part A, we apply intercept theorem and we find that, okay, G actually is also the midpoint of AF. So now in this triangle, actually, you have a pair of parallel lines, DG parallel to EF, and also you have two midpoints, D and G are midpoints. So actually in this green triangle, you may choose to apply midpoint theorem or intercept theorem. Just see what results you want. This time the results I want is the length relation between DG and EF. So which one? Midpoint theorem or intercept theorem can provide you this result. It should be midpoint theorem, the relation between the length. So let me rewrite the solution again. For the solution in the book, read it yourself if you want. Okay, so since AD equals to DE and AG equals to GF means both of them are midpoint, therefore I have this one, DG equals to half of EF. Okay, this is midpoint theorem. Okay, this is midpoint theorem. So we find the ratio. And I go on. We relate DG and EF together. But actually, finally, for part B, the result, we have to relate DG to DC. So we have to further relate EF to the whole line DC here. So how? How? You can try to focus on this triangle this time. Okay, this is for the green part, and this is the following is for the yellow part. Focus on this yellow triangle. In this yellow triangle, what can you observe? For me, I can observe that E and F are midpoints again. So we have a triangle with midpoints. We can apply midpoint theorem. So if we apply midpoint theorem, we can have some results about the length of EF and the length of DC. So since BE equals to ED and BF equals to FC, both of them are midpoints. Therefore, we have EF equals to half of DC. This is the result from midpoint theorem. Okay, so now by combining these two, this one and this one, we can see that, oh, as a result, DG equals to half of EF, EF equals to half of DC. So DG equals to, let me write this way, equals to half of DC. So finally, you can see this one. dg equals to 1/4 of dc. Therefore, the ratio dg to dc equals to 1 to 4. Same as the answer here. Okay, so we can see that in this question, in this part, we apply midpoint theorem to different triangles. Okay, to different triangles to get the result we want. Okay, so this is the end of this session 7.5, and actually this is the end of the whole chapter 7, and I hope you get your self-assessment booklet at home and you have to finish some corresponding exercise. Yes, and in the coming online lesson we'll still discuss some more questions about this chapter. Okay, bye.